calculation of sigma bonds and pi bonds. Let us see example. Take, see, how do you calculate number of sigma bonds? Number of sigma bonds equal to total number of atoms, take down, minus 1. So therefore, number of sigma bonds equal to total number of atoms minus 1. So this is applicable for acyclic compound. Acyclic compound. For cyclic compound, number of sigma bonds equal to, it is just total number of atoms. This is for cyclic, like benzene like compounds, cyclic compounds. Okay, let us see example. Take down methane. Tell me, so methane has how many sigma bond and which type of sigma bond? That is also important. So methane has how many sigma bond? So before that, you tell me methane undergo which hybridization? In last class we have studied, it is sp3, right? Methane undergo sp3 hybridization. It form how many, methane form how many sp3 orbitals? 4 sp3, very good, 4 sp3. Therefore, it is like methane, carbon has 4 sp3, 1, 2, 3, 4. Okay, now each sp3 orbital is overlap with which orbital? S orbital of hydrogen. Therefore, now which sigma bond is present here? It is a sp3, this is a S. Which bond is, this bond is called what? sp3s. There are how many sp3s? 1, 1, 2, 3, 4. Therefore, now tell me number of sigma bonds. Number of sigma bonds are 4. Then what are the types of the sigma bond? There are 4 sp3s sigma bonds. Next, then how many number of pi bonds? It is 0. There is no pi bond in methane. Next, example 2. CH3, CH3. Come on, tell me. To identify the bonds, first identify hybridization. It is sp3. This is also sp3. Then in between carbon carbon there is one sigma bond, no? Yes or no? Yes. And in between carbon hydrogen how many sigma bond? 3. Here 3, 6. 6 plus 1. And moreover total number of atoms are how many? 2 carbon, 6 hydrogen. 8. 8 minus 1, 7. Therefore total sigma bonds are 7. How many pi bonds? 0. But there are total 7 sigma bond. Which type of sigma bond? There is a sp3 sp3. In between two sp3 carbon one sigma bond is there, that is called sp3 sp3 sigma bond. Yes or no? Next, still there is a sp3 3 hydrogen. sp3 3 hydrogen. How many? There are 6, no? This is 1. Here is 6 sp3s sigma bonds. Next, example 3. CH2 double bond CH2. Come on, tell me. Here each carbon undergo sp2. It is also sp2, right? Come on, tell me. How many sigma bond total? Total sigma bond equal to atoms, total atom minus 1. Total atoms are how many? 6 minus 1, 5. Therefore sigma bonds are 5. How many pi bonds? Pi bond equal to 1. Then sigma bonds are 5. Which type of sigma bond? There is a one sigma bond sp2 sp2, no? In between two carbon, that is one sp2 sp2 sigma bond. Next, then there is a sp2s. Sp2s, how many? 4. So there are 4 sp2s sigma bonds. And what about pi bond? See, pi bond usually is because of p pi px px or py py. Therefore there is a one pi bond. This one pi bond may be px px overlapping, it may be py py. So you can take anything, any one also. That is one pi bond. That is a which pi bond? You can take, it is a px px overlapping pi bond. Next, CH triple bond CH. How many sigma bond? Sigma bonds, total number of sigma bond equal to total atom minus 1. How many atoms? 4. 4 minus 1, 3 sigma bond. Sigma bonds equal to 3. Then how many pi bonds? Pi bonds equal to 2. Then which type of sigma bond, which type of pi bond? In sigma bond, it is a sp, it is sp. Therefore there is a one sp sigma bond. Next, there is a 2 sp sigma bonds. And there are 2 pi bond, no? So how 2 pi bond? One px px and another one is py py. So therefore one px px pi bond, px px pi bond, and another one is py py pi bond. One more example, benzene. Calculate number of sigma and pi bonds. First, so there are how many sp2 carbon? Total 6 sp2, no? All are sp2 only. sp2 sp2 sp2, here also sp2. Therefore now tell me, sigma bonds how many? Yeah, in case of cyclic compounds, the number of sigma bond equal to total number of atom. So how many total number of atoms? 12. Or else you can calculate this: 1 2 3 4 5 6 7 8 9 10 11 12. So therefore there are total 12 number of sigma bond. How many pi bonds? 3 pi bonds. Okay, tell me, in 12 sigma bond, which type of sigma bonds? See, there are 6 are, it is sp2, it is sp2, no? The overlapping between sp2 sp2, it is like this. So how many sp2 sp2 sigma bond? There are 6 sp2 sp2 sigma bonds, and there are 6 sp2 and there is s orbital, right? sp2s sigma bond, and there are total 3 pi bonds. Which pi bonds? So here px 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 px, all are px. Either you can take py py, like one px other py is not possible, you can take any one. So therefore total I will take 6 3 px px pi bonds. Okay, so in this we can calculate number of sigma bond, pi bond, and which type of sigma bond, which type of pi bonds. Next, factors affecting on hybridization. Factors affecting on hybridization. So in last class we have studied what is hybridization and how to calculate hybrid orbital and all completed. Okay. Right. So factors affecting on hybridization. So there are 4 factors affect the hybridization. 1, bond length. 2, bond strength. 3, bond angle. 4, electronegativity. And acidic nature. Right. So these are the 4 factors affect our hybridization. See, and tell me, first one is bond length. How does bond length is related to hybridization? So here we study bond length between the carbon, right? So is it hybridization of carbon is same in all organic compounds? No. The hybridization of the carbon depends on the what? It is the nature of the carbon, like alkane, alkene, alkyne. In alkane carbon, what is hybridization? sp3. Alkene carbon, sp2. Alkyne carbon, sp. Therefore, when hybridization changes, bond length also changes. That means, for example, if you take a carbon-carbon single bond, that is a sp3, sp3. So sp3 bond length is always 1.54 angstrom. Then carbon-carbon double bond, it is sp2. This is 1.34 angstrom. And sp, right, this is 1.20 angstrom. That means as the hybridization changes, bond length also changes. Now which bond length is more? sp3. sp3 bond length is always greater than sp2 then sp. That means if you take example like alkane, CH3, alkene, CH2 double bond, CH2, alkyne, CH double bond, CH. Tell me, what is the order of bond length? Which bond length is larger? Alkane, then alkene, then alkyne. So therefore, the bond length of sp3 carbon always greater than sp2 sp. Next, this is carbon-carbon bond length. Now let us take carbon-hydrogen bond length. In case of carbon-hydrogen, let us take carbon-hydrogen. It is a, in case of alkane, sp3. Alkene also having carbon-hydrogen bond, whereas it is a sp2. In case of alkyne, there is a carbon-hydrogen bond, but it is what? Triple bond, that is sp. Now tell me, bond is same. It is carbon-hydrogen, but the bond strength is different, bond length is different. In what way? See, if there is a sp3 and hydrogen, this bond length is always larger. It is approximately 109 picometer. So therefore, sp3 and H is bond length is more. Carbon sp to H is then less than sp-H. Then sp to H is, it is approximately 108 picometer and it is a 106 picometer. So therefore, as the hybridization changes, the bond length of the carbon changes, carbon-hydrogen also changes. Therefore, question is like this: in alkane, alkene, alkyne, in which of the following CH bond length is stronger? Stronger. Alkyne, because shorter the bond length, stronger the bond strength, right? Therefore, so in this way, hybridization related to, take down, don't wait for. Next, second one is bond strength. Okay, tell me, so what is the relation between bond length and bond strength? So we know that bond strength is inversely proportional to bond length. Right. So bond strength inversely proportional to bond length. That means as the bond length is decreases, like here from sp3 to sp, bond length is decreases, bond strength is increases. Therefore, what is the order of bond strength in case of alkane, alkene, alkyne? It's quite opposite. Let us take carbon carbon single bond, carbon carbon double bond, and carbon carbon triple bond. Tell me, in which of the following bond strength is more? See, bond, as the number of bonds increases, bond strength is increases. Do you know this number of bonds can be measured by bond order? So do you remember in chemical bonding we study bond order? So bond order equal to, or bond order directly proportional to bond strength. So more bond order means more number of bonds. As the number of bonds increases, bond strength is increases, bond order increases. Can you tell me what is the bond order of this? It is 1. There is 1 bond. What is the bond order? 2. Bond order 3. Now similarly, if you take a carbon hydrogen bond strength, it is alkane, alkene, alkyne. Among alkane, alkene, alkyne, which bond strength is more? Alkyne, right? Because this is a shorter bond now. Shorter the bond, more will be the strength. So this is the order of what? Bond strength. Next, third factor is bond angle. Right. So to understand bond angle, we need to understand first percentage of S character. Okay. Tell me, how do you calculate percentage of S character? Calculation of percentage of S character. Okay. So we know that in organic compound, carbon can undergo 3 types of hybridization. What are the 3 types? sp3, sp2, sp. Can you get other than this? Never. So carbon can have only these 3 possibilities: sp3, sp2 or sp. Now let us see what is the percentage of S character in sp3. Okay, in sp3, tell me. In sp3, the number of s orbital is 1. Total orbital is 1s 3p, 4 into 100, which is equals to 25% S character. Next, what is S character in sp2 orbital? So number of s orbital is 1. Total orbitals are 1 plus 2, 3 into 100, approximately 33.33% S character. Next, percentage of S character in sp hybrid orbital. There is a 1s orbital. How many total orbital? 1s, 1p, that is 2 into 100 equal to, it is 50%. Okay. Now tell me, now what is the relation between percentage of S character and bond angle? See, here bond angle is directly proportional to percentage of S character. It means as the percentage of S character increases, bond angle is increases. Therefore, take this relation, bond angle. This is for only hydrocarbon, not any other compounds. Bond angle is directly proportional to percentage of, yes, percentage of S character. Okay. Tell me. Now, what is the percentage of S character in alkane, alkene, alkyne? So let us take CH3, CH3, alkane, next alkene, next alkyne. Tell me, so what is the percentage of S character here? It is just 25. Here 33.33%. Here is 50%. Okay, tell me where the percentage of S character is more? Alkyne. Therefore, the bond angle of alkyne is 180 degrees. This is 120 degrees, and alkane is 109 degrees 28 minutes. Right? So the bond angle alkane always this 109 degrees 28 minutes, alkene 120, and alkyne is 180 degrees. Okay. So therefore, as the percentage of S character increases, bond angle also increases. And fourth one, most important factor is electronegativity. Electronegativity. Okay, tell me. So what is the relation between electronegativity and hybridization? So yes, there is a relation between electronegativity and percentage of S character. So therefore, here electronegativity of carbon is directly proportional to percentage of S character. As the percentage of S character increases, its electronegativity increases. For example, take carbon-carbon single bond, double bond, and a triple bond. Tell me, so what happened percentage of S character? Alkane, alkene, alkyne. It is increases, right? So since percentage of S character increases, what happened? The electronegativity. Therefore, the order of electronegativity is this. Electronegativity increases from sp3, sp2, sp. Okay, now question is like this here. Remember like this, sp3 carbon, sp2 carbon, and sp carbon. 3 are carbons only. Okay, do you remember what is the electronegativity of carbon? Classification of element we have studied. Electronegativity of carbon is 2 point, that is hydrogen 2.1. 2 point. Okay, tell me this. Among sp3 carbon, sp2 carbon, sp carbon, element is same, carbon only. But can you expect same electronegativity? No. Electronegativity depends on hybridization. There also we have studied. Here sp carbon has more En compared to sp2 carbon compared to sp3 carbon. That's what. Alkane, it is a alkyne carbon, more En. Alkene carbon, then alkyne carbon. No, sorry. Alkyne, alkene, alkane carbon. Right? Next, one more. If there is a oxygen, fluorine, oxygen, and carbon, tell me, among fluorine, oxygen, carbon, whose En is more? We know that fluorine has highest En. The next is oxygen, next is carbon, right? And moreover, what is the order of electronegativity of most electronegative element? Fluorine highest, next is oxygen highest, second highest, next is nitrogen, which is approximately equal to chlorine. Okay. Now if I want to write the order, tell me. So I can write fluorine has highest En, next is oxygen. After fluorine, oxygen, after oxygen, if I want to write carbon, all three carbon, tell me, Among all three carbon, which carbon has highest electronegativity? So obviously sp carbon has more. Next sp2 carbon has, next is sp3 carbon. Important. Okay. Now what is the importance of electronegativity in particularly organic compound? So this is we have studied. Electronegativity is directly proportional to acidic strength. Yes or no? So we also know that electronegativity of carbon is directly proportional to its acidic strength. Important. It means if electronegativity increases, acidic strength increases. When the En increases, En increases as the percentage of S character increases. So therefore, now I want order of acidic strength. Order of acidic strength. Let us take alkene, alkene, alkyne. Come on, tell me. Among alkane, alkene, alkyne, which is more acidic and why? Alkyne is more acidic than alkene, then alkane. Why? Because percentage of S character is more here. Right? Then this, then this, then this. Okay? Write one question. Which of the following is more acidic? Which of the following is more acidic? 1. H2O, 2. HF, 3. CH3, CH3, 4. CH2 bond, CH2. Take 5. CH triple bond, CH. Tell me. So which of the following is more acidic? You need to understand this. So fluorine has highest electronegativity, then oxygen, then sp carbon, sp2, sp3 carbon. Therefore here it is a oxygen sp3, here fluorine sp3, right? Here carbon sp3, here sp2 carbon and sp carbon. Okay. When compared with all the three carbons, oxygen and fluorine are having highest electronegativity. Among oxygen, fluorine, which is highest? Fluorine. Therefore HF is a most acidic. Then if I want to write order, tell me. Order of acidic strength. So generally acidic strength is denoted by Ka. We will study later. Ka called dissociation constant of weak acid. So K directly proportional to acidic strength. Come on, tell me, which of the following is more acidic? HF, more acidic. Then next is H2O. Next is acetylene, CH triple bond, CH. Next is ethene. Next is ethane. Yes or no? Next, one more. Which of the following is more acidic? One more question. Which of the following is more acidic? So instead of writing examples, I am giving as a question. That's it. Okay. Which of the following is more acidic? Now let me take here. All are alkynes only. CH3, C triple bond, CH3, B, CH3, C triple bond, CH2, CH3, C, CH3, C triple bond, CH, D, CH3, CH3. Tell me, which is more acidic and why? Okay, you just identify the hybridization. It is sp3, it is sp, sp, sp. Okay. Then D is not more acidic. So 1, 2, 3 means A, B, C are more acidic. But among A, B, C, which is actually acidic? Only C. Why? See, there is a one reason. Tell me. The alkynes which are having acidic hydrogen, that is called terminal hydrogen. Alkynes having terminal hydrogen, that means this hydrogen should be present on where? sp carbon. If hydrogen present on sp carbon, which is called acidic hydrogen or terminal hydrogen. Alkynes having terminal hydrogen only acidic. If I ask question, is it acidic? Your answer should be no. It is not at all acidic. It is equal to alkane only, because triple bond is there. But on triple bond carbon, is there any hydrogen? No. If triple bond carbon has no hydrogen, actually this is electronegative, this is electronegative carbon. On electronegative carbon, there is no hydrogen. Then what is the use? That hydrogen cannot come out. So therefore, this cannot produce hydrogen, this cannot produce H plus ion, this can produce H plus ion, because on sp carbon there is a hydrogen. So therefore, note is, right, take one note. Alkynes having terminal hydrogen, only acidic in nature. Alkynes having terminal hydrogen only acidic in nature. Therefore, this is only acidic in nature. Okay, next. Now let us see one more example. Let us take alkane, alkene, alkyne. Alkane is CH3, CH3. Come on, tell me. If it is donate the proton, what it form? CH2 negative plus H plus, no. If it is act as a acid, it must donate the proton. If it donate the proton, it form carbanion plus H plus. It is called carbanion, carbon carrying anion. Next, 1, 2. Let us take alkene. Alkene also donate the proton, it form carbanion H plus. 3. Alkyne. It also donate proton to form H plus. Now my question is, which of the following process takes place easily? 1, 2, 3. Or which of the following can donate proton easily? Third one, right? So therefore, alkyne can donate the proton easily to form this anion. Okay, therefore, which is a strong acid? Strong means comparatively. Okay, so comparatively, third one is a strong acid. But do remember, acid donate the proton to form conjugate base. Every acid donate the proton to form conjugate base. If it is an acid, donate the proton, it form what? This is a conjugate base. Okay, if you take this is a acid, this is what? A conjugate base. If this is a acid, so acid donate the proton to form its conjugate base, right? Therefore, all acids donate proton, they form conjugate base. And we also know that weak acid forms strong conjugate base, strong acid form weak conjugate base, right? Therefore, if you take weak acid, it gives strong conjugate base. If you take strong acid, it gives weak conjugate base. Tell me now, based on this concept, acid form conjugate base, weak acid form strong conjugate base, strong acid form weak conjugate base. Now my question is, all these are bases. It is alkane, alkene, alkyne bases. Among these base, which of the following base is more basic? Which of the following has more basic strength? Tell me. First option, because it is acid. No, which acid? Among this, it is a weak acid. Weak acid base is always strong base. Therefore, if I ask question, what is the order of basic strength? order of basic strength. So which is a more basic? First one, that is formed from alkane. Which is more basic? The next is from alkene, next is from alkyne. Next, which of the following strong base and of course weak base also? Which of the following strong base and weak base? Option 1, OH minus 2, F minus 3, 4, 5. Tell me. Among these 5, identify strong and weak and even arrange basic strength also. So to identify this, you need to identify first acidic strength. You just write their acids, corresponding acids. It is H2O. Its corresponding acid HF. Its corresponding acid ethane, ethene, right? So write their corresponding acids. In among these acids, which acid is a strong acid? Because acidic strength directly proportional to electronegativity. Electronegativity, this is more, therefore it is a strong acid. Since it is a strong acid, it is a weak base. That's it. So strong acid always form weak base. Got it? Now next is, among this, which is a weakest acid? See, in all hydrocarbons, alkanes are weakest acids, right? Since alkanes are weakest acid, this is a strongest base. That's it. Okay. Now, will you arrange the decreasing order of basic strength? Basic strength denoted by Kb. Kb is a dissociation constant of weak base. So arrange the decreasing order of Kb. Now tell me, which is a most basic? Third one. Yes or no? No, 1 second. Yeah. Strong base, no? Strong base B, that is 3. Next is next 4. Next is 5. Next is 1. Next is second. So that is the decreasing order of basic strength. Okay. Next is order of electronegativity of different orbital. This was a question previously appeared in CET. Different orbital. Even in chemical bonding also we study. So what is the order of electronegativity of the different orbitals? Let us take s orbital, comma, sp, sp2, sp3 and p. See, we know that electronegativity of any carbon or any atom is depends on what? Its particular carbon atom depends on percentage of s character. As the percentage of s character is increases, En is increases. As the percentage of s character decreases, En is decreases. Can you tell me what is the percentage of s character s orbital? It is a percentage, 100, no, there is no other orbital. 100%. Here is 50%, next 33.3%, next 25%, next 0%. So pure p orbital has only p percentage, no s percentage. So therefore, now tell me, what is the order of electronegativity? So pure s orbital has highest electronegativity. Then next is sp, next is sp2, then sp3, then p. So this is the order of electronegativity, important. Next, order of size of different orbitals. Okay. So order of the size of the orbital. See, let us take again same S, sp, sp2, sp3 and p. Now tell me, among these orbital, which orbital has smallest in size? Obviously, yes, no. S orbital is, it's very small in size, right? Then it means S orbital is very small. It means as the percentage of S character decreases, as the percentage of S character decreases, the size of the orbital is increases. Then what is the relation between size and S character? Inversely proportional. The size of orbital is inversely proportional to what? Percentage of S character. That's it. Then here, now tell me, we want order. What is the size of S orbital? Least, smallest size. Then next is sp. Yes or no? Next is sp2. Next is sp3. Next is p. Important. Right? Order of different orbitals, size of the different orbital. Okay, third one question. Which of the following carbon has highest electronegativity? Which of the following carbon has highest electronegativity? One, two, three, four, 5, 6. Identify the carbon which has highest electronegativity. Which carbon? That is C2, because sp hybridization. Okay. Next. Okay. So these are the factors affecting on hybridization. So related to hybridization concept, all the concepts are covered. Okay. So next we have degree of carbon, degree of hydrogen, degree of halogen, degree of alcohol, degree of amine. Okay. Right, one by one. First write degree of carbon. Degree of carbon. Right. Right. See, degree of carbon, it is based on the attachment of carbon. The based on attachment of one carbon to how many carbon atoms? It is classified into how many types? 4 types. Primary carbon, secondary carbon, tertiary carbon and quaternary carbon. 1 degree, 2 degree, 3 degree, 4 degree carbon. So therefore, this classification made is based on what? The attachment of one carbon atom to how many carbon atoms? Right. Therefore, based on attachment of carbon atom, based on attachment of carbon atom to other carbon atoms, based on attachment of carbon atom to other carbon atoms, carbon atoms classified into 4 types. 1, primary carbon atom, or you can take primary carbon, it's enough. Primary carbon, it is also called 1 degree carbon. Tell me, what is a primary carbon? Secondary carbon, tertiary carbon, quaternary carbon. Tell me, so what is primary carbon? So primary carbon is, the carbon, the carbon atom which is attached to. So if carbon atom, it is attached to only one adjacent carbon. For example, you take this carbon atom attached to only one adjacent carbon, then this particular carbon is called primary carbon. If carbon atom attached to 2 adjacent carbon atom like this, and this is called what? Secondary carbon. If carbon atom attached to 3 adjacent carbon atoms, which is called tertiary. If carbon atom attached to 4 adjacent carbon atoms, okay, so now this is called what? Tertiary, quaternary, right? Therefore, take in short form, primary carbon atom attached to, if carbon atom attached to one adjacent carbon, if carbon atom attached to only one adjacent carbon atom. So if carbon atom attached to only one adjacent carbon atom called primary carbon, then what is secondary carbon? 2 degree carbon. If carbon atom attached to, right, 2 adjacent carbon atoms. If carbon atom attached to 2 adjacent carbon atoms, secondary carbon. 3 degree carbon is, if carbon atom attached to 3 adjacent carbon atom, tertiary carbon. Quaternary or 4 degree. If carbon atom attached to 4 adjacent carbon atoms called quaternary carbon. Okay. Understand? So take one question. Identify the primary, secondary, tertiary and quaternary carbon in the following. Identify the primary, secondary, tertiary and quaternary carbons or carbon atoms in the following. You just identify. Okay. 1 CH3 CH3. Come and tell me. What about this carbon is primary? This is, it is also primary, right? Next, 2 CH3 CH2 CH3. Tell me. See, if there is a CH3, it must be primary only. It is secondary. Next, tell me. This is primary, primary, primary. This is tertiary. Fourth one, okay. Tell me. Here, all CH3 are primary, but this is quaternary carbon. Tell me here. Primary, tertiary, primary, all CH3 primary. This is quaternary carbon. Sixth one. Tell me. This is secondary, no? Secondary, secondary. This is tertiary. This is secondary. It is quaternary. It is huh? Secondary, tertiary. See, this carbon atom attached to 2 carbons, no. It is attached to chlorine, let it be. But what is the secondary carbon? The carbon atom, if it is attached to 2 adjacent is secondary. If it is a 3 adjacent carbon, tertiary. It is attached to chlorine, not carbon. That's what it is not a tertiary. It should be only secondary. If carbon atom attached to 2 adjacent carbon, it's always secondary. You need not to see other atoms. This is primary. It is secondary. This is secondary. It is primary. Tell me. Secondary, secondary, tertiary, secondary, secondary, tertiary, second. Correct, no? Secondary, secondary, primary. Which one secondary? Secondary. This is tertiary. It's secondary only. 1, 2, no. This one secondary. Okay, okay. It's bromine. Secondary. So it is a degree of carbon. Next, degree of hydrogen. Degree of hydrogen. Okay. Now see, it is based on presence of hydrogen on which carbon, or based on presence of hydrogen on which carbon the hydrogen are classified into primary, secondary, tertiary, right? There is no quaternary hydrogen. Quaternary carbon is there but no quaternary hydrogen. So therefore there are 4 types of hydrogen. One, written, primary hydrogen, it is called 1 degree hydrogen. 2, secondary hydrogen. 3, tertiary hydrogen. Okay. And tell me, now we want what is the primary hydrogen. Tell me, what is the primary hydrogen? If hydrogen atom present on primary carbon, that's it, right? If hydrogen atom present on primary carbon in hydrocarbon, which is called primary hydrogen, or if hydrogen atom present on secondary carbon is secondary hydrogen, tertiary carbon is tertiary hydrogen. So therefore what is the primary hydrogen? If hydrogen atom present on primary carbon, if the hydrogen atom present on primary carbon, primary hydrogen, if hydrogen atom present on secondary carbon, called secondary hydrogen, on tertiary carbon called tertiary hydrogen. Okay, so therefore okay, now tell me. So if hydrogen atom present on primary carbon is called primary hydrogen. If hydrogen atom present on secondary carbon is called secondary, tertiary carbon is called tertiary hydrogen. Okay, so write down question. Calculate the number of primary comma secondary comma tertiary hydrogens in the following. So calculate number of primary, secondary, tertiary hydrogen. How many primary hydrogen? It is a primary carbon, no? We first identify carbon, primary carbon, primary carbon. So 3 plus 3, 6. There are primary hydrogens are 6. No secondary, no tertiary. Next here tell me, this is primary carbon, primary carbon, primary carbon. This is tertiary carbon. Huh? Yes or no? 9 okay. Primary carbon primary hydrogens are 9, tertiary hydrogens are 1, no secondary. Next here primary secondary, this is quaternary. Okay, tell me how many primary hydrogen? 3, 15. So there are 15 primary hydrogens. How many secondary? 1 secondary hydrogen. How many tertiary? It is tertiary, secondary? Tertiary no? ನಾನು ಏನು ಬರ್ತದೆ ಅದೇ ಹೇಳ್ಬೇಕು ನೀವು ಯೂಸ್ ಮಾಡಿರಿ ಸ್ವಲ್ಪ. ನೆಕ್ಸ್ಟ್ how many tertiary? Quaternary? Is there quaternary hydrogen? Quaternary carbon is there, but there is no quaternary hydrogen because carbon has 2 hands, 2 legs. ಹೌದು ತಾನೇ? ಇನ್ನೊಂದು ಹ್ಯಾಂಡ್ ಇಲ್ಲಿ ಇಟ್ಟರೆ ನೋಡೋಕ್ಕೆ ಚೆನ್ನಾಗಿ ಕಾಣಿಸಲ್ಲ, ಡಸಂಟ್ ಲುಕ್ ಗುಡ್, ರೈಟ್? ಸೊ ಟೆಟ್ರಾವೆಲೆನ್ಸಿ. ವಿಲ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್? ಆಮೇಲೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. Next, degree of alkyl halide. Right, so degree of carbon over degree of hydrogen is completed. Next is degree of alkyl halide. Right, so this is, it is also similar. It is based on attachment of halogen to carbon. So based on attachment of halogen to the carbon, again haloalkanes or alkyl halides are classified into 3 types: primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. Tell me, what are primary alkyl halide? If halogen present on primary carbon, primary alkyl halide. If halogen present on secondary carbon, secondary alkyl halide. If the halogen present on tertiary carbon is tertiary alkyl halide. So what about quaternary alkyl halide? Quaternary carbon is there, but on quaternary carbon, so no atom can attach because already it has 4 not 4 legs. ಹೇಳ್ಬಿಟ್ರೆ ಏನು ಹೇಳ್ತಿರಲ್ಲ. Okay, so degree of alkyl halide, right on, based on attachment of halogen to carbon atom, based on attachment of halogen to carbon atom or on carbon atom. Alkyl halides are classified into 4 types. Alkyl halides are classified into 4 types. 1. Primary alkyl halide. Primary alkyl halide, it is called 1 degree Rx. 2. Secondary alkyl halide, 2 degree Rx. 3. Tertiary alkyl halide, 3 degree Rx. Tell me now. So what are primary alkyl halide? If halogen present on which carbon? Primary carbon. If halogen present on primary carbon, if halogen atom present on primary carbon, primary alkyl halide. Similarly, if halogen, that is X, present on secondary carbon, secondary alkyl halide. If halogen present on tertiary carbon, called tertiary alkyl halide. Which one? Which one? Fifth one. Fifth one second rank ಆಗುತ್ತೆ. No, second ಆಗುತ್ತೆ. ಎಲ್ಲಿ?
Hydrogen which are present in secondary carbon secondary hydrogen.
If hydrogen present on secondary carbon, there is no hydrogen. It is a carbon secondary, but hydrogen is not there. No, irbo tane. Carbon is secondary carbon. What are the secondary hydrogens? Zero, no hydrogen. Halogen is present, that's what, no secondary hydrogen, but secondary carbon is there. Okay, fine. Next, tell me, it is write on question. Identify the primary comma secondary and tertiary alkyl halide in the following. Identify the primary comma secondary and tertiary alkyl halides in the following. CH3, CH2X, X I'll take clearly, Cl, 2, CH3, Cl, CH3, 3. You understand, no? ಇದು ಎನ್ನಲ್ಲ, ಇದು ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ಲ. ಏನನ್ನು ಬರ್ಕೊಬೇಡ್ರಿ, ನಾನು ಹೆಚ್ಚು ಇದೇ ಥರ ಬರಿತೀನಿ ನಾನು. So identify the primary, secondary, tertiary alkyl halides. Tell me first one. Okay, see here, you first identify the carbon. So what is the carbon of this? Because halogen present on this carbon, no. identify the halogen present carbon. Which carbon it is? Primary. Therefore, it is a primary RX. Right. So wherever halogen is present, okay, that carbon becomes that particular alkyl halide. And tell me, this is what? Secondary. Therefore, it is a secondary RX. RX is a alkyl halide. Next, what about this? This is a tertiary carbon, tertiary RX. Next here, it is a secondary carbon, secondary RX. Next, it is tertiary carbon, tertiary RX. Here, it is secondary RX. Next here, secondary, tertiary, tertiary RX. Okay. It is about degree of alkyl halide. Next, degree of alcohol. Degree of alcohol. Tell me, it is also same. The based on attachment of OH group to what? Carbon atom. So based on attachment of OH group to the carbon atom, again alcohols are classified into primary, secondary, tertiary. Okay. Then what are primary alcohol? If OH group is present on primary carbon, primary alcohol. If OH group present on secondary carbon, secondary, tertiary carbon, tertiary. Right? Based on attachment of OH group to the carbon atom, based on attachment of OH group to the carbon atom, alcohols are classified into three types. Primary alcohol, okay. Is there quaternary alcohol possible? No. So quaternary carbon is possible, but quaternary alcohol is not possible. Aishwarya, why? Naniಗೆ ಯಾಕೆ ಕೇಳ್ತೀರಿ ಸರ್ ಅಂದ್ರೆ ನಾನೆಲ್ಲ ಮೂಲೆಯಲ್ಲಿ ಕೂತ್ಕೊಂಡಿದ್ದೆ, ನನಗೆ ಯಾಕೆ ಕೇಳ್ತೀರಿ ಸರ್ ನೀವು ಕ್ವಶನ್? ಇಷ್ಟು ಜನ ಕೂತ್ಕೊಂಡ್ರಲ್ಲ ಮುಂದೆ, ಅವ್ರಿಗೆ ಕೇಳ್ರಿ. ಹಾಂ, right. So what are primary alcohol? Yeah, that's answer ready. Quaternary carbon is there, quaternary alcohol is not there, because quaternary carbon already is valency satisfied now. On quaternary carbon there are 4 bonds, right? Its valency already satisfied. Therefore you cannot have another like OH bond here like this. ನೀವು ಬರಿಬೋದು, ಅರಿಬೇಕಲ್ಲ. Okay, so that is tell me now primary alcohol. What is primary alcohol? If OH group is present on primary carbon, if OH group is present on primary carbon, primary alcohol. Similarly, if OH group is present on secondary carbon, secondary alcohol. If OH group is present on tertiary carbon, is tertiary alcohol. Okay. Identify the primary, secondary and tertiary alcohols in the following. Okay. ಯಾರೇನು ಕೇಳ್ತಿಲ್ಲಲ್ಲ? ಟೈಮ್ ಆಗಿದ್ದು ಯಾರು ಕೇಳ್ತಿಲ್ಲ? ಹಾಂ, ಕೇಳಿದ್ರೆ ಕ್ವಶನ್ ಇರುತ್ತೆ ಒಂದು. ಕಂಟಿನ್ಯೂ ಮಾಡಲಾ? ಬ್ರೇಕ್ ಬೇಕಾ? ಕಂಟಿನ್ಯೂ ಮಾಡಿದ್ರೆ 10 ಮಿನಿಟ್ಸ್ ಮುಂದೆ ಬಿಡ್ತೀನಿ. ಬ್ರೇಕ್ ಕೊಟ್ಟರೆ 10 ಮಿನಿಟ್ಸ್ ಜಾಸ್ತಿ ತೊಗೋತೀನಿ ಅಷ್ಟೇ. ಚಾಯ್ಸ್ ನಿಮ್ಮದು. ಓಕೆ. It is which alcohol? Primary, right? So identify the carbon astray. Primary carbon. So on primary carbon OH group is present, therefore it is a primary alcohol. Okay, OH group is present on secondary carbon, secondary alcohol or OH. On tertiary carbon there is a alcohol, therefore it is a tertiary alcohol. This is secondary, no? On secondary carbon there is a alcohol, therefore OH group, it is secondary alcohol. Tell me this. It is also secondary or OH. It is tertiary or OH. Next, primary or secondary? Primary, because this carbon is a primary carbon. It is attached to only one adjacent. Don't look at on this. This is of course tertiary. It is primary. So it is a primary alcohol. It is primary alcohol. Okay. Next is degree of amine. Okay. Let us give 5 minutes break. Off ಮಾಡ್ರಿ.